Good afternoon and welcome to this webinar, Gain Competitive Advantage Developing Innovation Networks. Thank you for joining. Let me first introduce myself. My name is Héloïse Naudy. I am product consultant at Expernova. If you have any questions, please feel free to use the question tool on GoToWebinar and I will answer at the end. If I don't have enough time to answer your questions, we will come back to you with personalized answers. You can also contact us by email on the following address, contact@expernova.com, or on my personal email, enaudy@questel.com. So this webinar will last around 30 minutes. In the agenda of today, I propose you to discover through a use case and an online demonstration of the Expernova platform how to easily identify essential networks between small and large corporations, startups, academics, and laboratories on your research topic. To do so, we will start by obtaining a global vision of collaborative networks on your research topics. Then we will evaluate the relevance of an organization's scientific and technological expertise on your science-specific topics. And then we will see how to capitalize on the knowledge acquired thanks to the collaborative features. But let's first take 2 short minutes to explain and set the context. So first, let's start to define the innovation networks. So networks are those linked organizations, such as companies, universities, or laboratories, that create, acquire, and integrate the diverse knowledge and skills required to invent technologies, develop new scientific concepts, and adapt new processes. In other words, innovation networks are organized around constant learning. Collaborations boost innovation. Collaborations are a tradition in research. They correspond to a pooling of culture, techniques, skills, and allow to enrich practices and stimulate innovation. Thus, successful innovation networks allow to gain access to resources otherwise inaccessible, such as completely new sources for innovation, skills, market, and application possibilities. They offer a sizable cost reduction potential to the participant. Networks maintain and increase the innovation capacity and generate competitive advantages. To stay innovative when developing new products and processes in a fast-paced environment, organizations have to source technology, scientific knowledge, and look into different domains, ideas, and expertise. Thereby, industrial and academia embrace open innovation engagement to complement their core expertise with knowledge and talents by building relationships and creating interaction at local and international levels. Mapping those collaborative networks through which the production of new knowledge in science and technology is spread will clearly contribute to the unraveling of where the expertise is, open organizations to more innovation opportunities, and definitively help them to be more competitive. Thanks to network intelligence, organizations can take more informed decisions. That's why, since 2009, Expernova creates an innovation graph data model of the experts, innovative companies, universities, network, and knowledge that pinpoint innovation opportunities for every industry. At Expernova, we offer you access to expertise via the identification of innovative players. So Expernova has been founded in 2008, and Expernova is a big data platform that aims to help you understand the innovation activity of your competitors, partners, suppliers, and customers through the analysis of scientific and technological expertise. How does it work? By tracking and analyzing global innovation work, such as scientific publications, patents, conferences, clinical trials, projects, and millions of targeted web pages, Expernova provides its user with accurate mapping of the most innovative stakeholders at a global level. Our core business is to map innovation players at a global scale. Indeed, Expernova creates an innovation graph data model of the experts, innovative companies, universities, networks, and knowledge that pinpoint innovation opportunity for every industry. These graphs building blocks come from the scientific and technological data collected all over the world, targeting the innovation leaders, linking expert with organization, and tracking the collaborations. This information is stored in our database model that emphasizes the relationships between entities. To do so, Expernova collects and analyzes the metadata of scientific works, that is to say the publications, the patents, the projects, and the clinical trials, to extract expertise and scientific and technology collaborations in order to create mapping around specific research topics. Each month, new data is collected, curated, and integrated into the graph, creating a unique and dynamic asset. Millions of skills, technologies, or methodologies are identified and added to the innovation profiles of the targeted stakeholders. This huge and unique knowledge allows to detect newcomers, rare skills, and moves. The assessment of rival or partner relationships and capabilities reveal high-level expertise, opinion leaders, and strategic moves. Explore relationships, mixed duration, emerging topics, size of firms in relationships, strengths and position in the relationships, location of collaborations, and so on. So why using Expernova to identify innovative actors? First, because the database is continuously improved. The Expernova database is unique with its continuous aggregation since 2008. Secondly, because Expernova offers you a global and multi-sectoral analysis of scientific and technological data. The Expernova database covers three main geographical areas: North America, continental Europe, and Southeast Asia. I take the opportunity to announce that Expernova is currently carrying out an important update, which will be finalized at the end of January 2019. Expernova will extend its geographical coverage and will thus have a global coverage and not only on these three geographical zones. So Expernova will therefore go from 52 countries covered to more than 195 countries. Then, Expernova covers more than 400 scientific domains. The database of scientific documents on which Expernova is based includes more than 300 different data sources, such as based of research institutes, national bases, open access bases, thematic bases, university bases, and so on. Finally, Expernova offers a single web interface that gives you access to different types of scientific and technological works. The database includes 5 types of scientific works. First, the scientific publications, such as peer-reviewed articles, theses, conference proceedings, and so on. Second types of scientific works, the patents, the European collaborative projects, such as the FP5, FP6, FP7, and H2020 project, and also the American projects, the SBIR, Small Business Innovation Research, and the STTR, Small Technology Transfer Research. The last type of scientific works included into the database are the clinical trials and also the declarative data, that is to say the web pages and the skill description communicated by the organization on their websites. Expernova database includes today 82 million of patents, 40 million of scientific articles, 280,000 clinical trials, 250,000 projects. And I take the opportunity to announce that we are currently carrying out a very strong integration of new scientific works into the database. So today we have 40 million of scientific articles in the database, and we will pass at the end of January 2019 to more than 1,030 million of scientific articles in the database. Finally, Expernova gives you real-time access to global scientific and technological knowledge through monthly platform updates every month, 1,000 new organizations and 500,000 new documents are added to the platform. Expernova is the only platform that tracks and analyzes global innovation activities to generate dynamic and rich innovation profiles of organizations and experts. Expernova's innovation profiles synthesize the expertise, the experience, and even the influence of innovation players, both at the level of individuals and organizations such as companies, university, research institute, cluster, and so on. So you can save up to 5 days of data compilation with an Expernova profile. So by combining big data and human curation, Expernova has created rich and structured profiles that link experts with organizations, subsidiaries with groups, research teams with universities. On a single profile, you will have a complete overview of the innovation activity. You can easily identify the positioning of their work from early stage projects, such as the academic works and the exploratory R&D, to industry applications. You can easily understand the openness to collaboration, national or international dimension, academic or business-oriented activities, and potential risk of competition. Expernova gives you immediate insights to understand why an expert or an organization is relevant on your specific topic. The system explains you the player experience, networks and communities, people and works, and provides you a synthetic overview. You can also compare two players and identify in a few seconds their common competencies or specificities. So today, I will take you through a common use case demonstrating how to use the Expernova platform to easily identify the essential networks between companies, startups, universities, and laboratories on your specific research topic. So for this demonstration, I would like to show you how to analyze the collaboration networks of organizations working on three-dimensional printing. So to do so, we will switch to the Expernova platform, and the first step is to start a search on our research topic. So to do so, you have to enter your query into the search field like this. So you can see that I have entered the different keywords that represent the concept of 3D printing in order to retrieve the maximum document related to 3D printing. Finally, click the search button to run the query and view the search results. So here is the search result interface on 3D printing. So the goal here is to get a global vision of the actors working on my research topic. So first, let's take a quick look at the search result interface for this query on 3D printing. So at the top of the screen, you see a header that shows you your query, and below you have 6 pictograms combined to a color code that show you the type and the number of results. That is to say that on our query, Expernova has identified 35,000 of individual of experts working on the 3D printing. In gray, you have the organization, so it means that Expernova has identified 2,400 organizations working on this topic. And then in yellow, we have the scientific publication. In orange, you have the patent families. In red, you have the projects. And in green, you have the clinical trials related to 3D printing. Underneath the header, you have access to list and graph. So from the different list, you can access to the list of experts, that is to say the individual working on 3D printing. And then below, you have the list of the organization working on 3D printing. So they're being divided between the industrial organizations, so the company and the startup in the company block. Then you have the labs, so the R&D centers. And then in the academic blocks, you can find the academic organizations, that is to say the universities, the hospitals, the public research institutes, and so on. And finally, at the end, you have the list of the scientific publications, so you have an access to this publication, the list of the patent families, the projects, and the list of the clinical trial related to 3D printing. So I would like now to show you the collaborative network graph here. So this graph is the network of players formed around the subject, and it allows you to visualize the main interaction between the R&D centers and the companies on 3D printing. So the interaction can be scientific collaboration, such as a co-publication or a participation to common projects. Each bubble represents an organization, and it's clickable, so you can display the profile of this organization. And the more an organization has a strong activity of collaboration on our topic, on the 3D printing, the more it is highlighted on the graph, the bigger the bubble is. So on our topic 3D printing, let's go in details to see what kind of organization we have. So we can see the DMSE and the MECHE, which are departments from the MIT. So we've got academic organization there. And we have also companies. For example, here we have the 3D Systems company, Philips, ST Microelectronic Groups, Borealis, and so on, and also another Institute of Technology, the Calrouche Institute of Technology. So by flying over the bubble like this, you can visualize the main collaboration of this organization. For example, we can see that the Calrouche Institute of Technology has collaborated with companies such as 3D Systems, Stratasys, Borealis, Philips, and so on. We can also see some nodes of expertise on this topic. So for example, here, so for example, the Danish Research Institute, the SINTEF, let me zoom in here, has collaborated with many organizations and is a bridge between the various networks. So it shows that collaborating with this research institute could allow you to access to this other network of actors more easily, and thus it allows you to develop relations more quickly. It also confirms that this research institute is a center of recognized expertise and it has experience in collaborative projects. This player could therefore be an interesting partner for the acquisition of new expertise and accelerate the development of your products. Finally, we can see also a peripheral network that are also working on our topic, the 3D printing. So being isolated, one could imagine that they hold specific expertise or work on other applications of 3D printing. One could therefore wonder if this actor come from another scientific field, and access to their expertise and their scientific work could therefore allow you to discover new applications. So thanks to this graph, I can also identify in a few seconds my competitors, understand with whom they work and on what subjects. So this allows me to remain vigilant on their progress and to anticipate their next orientations. So to summarize, this graph gives you an overview of the network of collaboration of the main actors working on 3D printing. It allows you to identify the actors' games around the 3D printing in order to quickly detect who is working with whom on your subject and on which applications. It allows you also to understand the networks of collaboration of your competitors and to access their co-works. It allows you to identify centers of expertise to develop your networks, and it allows you to zoom in on the actors in order to understand their expertise, their scientific domain, their geographical position, whether they work on new application or not. So now let me show you how to evaluate the relevance of the scientific and technological expertise of this organization on your topic. So to do so, we will take as an example the organization 3D System, it's a company. So you can zoom in here. And so each bubble represents an organization. And by clicking on the bubble, you can view the organization profile on the right of the screen, like this. And so here, the 3D system profile is displayed on the right. So you can immediately access to a summary of the expertise of 3D systems on 3D printing. So to go further, we will open the full profile of 3D system by clicking on Open. So first, we are going to verify the expertise of 3D systems. So here you have an access to the expertise of 3D system. The expertise, where does it come from? It is automatically calculated from the scientific production of 3D system. Sorry. So it's avoid you to read all the publication and patents done by 3D system, and to quickly verify that the expertise of the organization is on your topic. So here we can see the dimensional printing and the additive manufacturing. Then we are going to the why part here to understand why the company's 3D systems is relevant on our topic. So Expernova analyzes for you why 3D system is relevant on 3D printing thanks to the why. We can thus see that 3D system has been working. So you have some element in terms of experience, networks and community, and people and works. So in terms of experience, we can see that 3D system has been working on 3D printing for 20 years now. He has recently published works on the topic, so it means that they are still working on the 3D printing. And the topic is quoted in the organist description. Then, on the people and work section, Expernova has identified the expert of 3D system who are working on 3D printing, and Expernova has also identified the publication, so 15 publication at 3D system related to 3D printing, and it's clickable, so you can access the publication. Same with the patent, so we have identified 60 patent families of 3D system related to the 3D printing. And also, thanks to the web crawling, we have extracted the web pages of 3D system related to 3D printing. And finally, in the networks pane, we can see that a 3D system has 15 collaboration with different organizations on 3D printing. So before I show you the collaboration network, let me show you that you have the name of the best connection on the topic. Here, the University of Malaysia. You can see that the connection are located in 9 countries, which gives you an idea of the influence of 3D system on this topic. You can see also that 3D system has participated to one project related to 3D printing. And sorry, it's a project that is in progress. And Expernova has identified the 6 subsidiaries of 3D system that are working on 3D printing. Now, let's look at the 3D system collaboration network on 3D printing. And to do so, you click on 15 connections. So here you can see the organization with which 3D systems collaborates or has collaborated on 3D printing. So in the middle, you have the 3D systems, and all around you have all the organization with which 3D system has collaborated on the 3D printing. You have exactly the same information under the form of a list below. Then you have some graph here. The graph gives you information about the nature of the 3D system networks. First graph is a classes graph, so it allows you to visualize the distribution of the collaboration by type of organization. So here we can see that the collaboration of 3D system are done at 53% with university and 27% with company. So we can say that on this topic, 3D systems as a network mainly academic. Then you have the country graph that show you the distribution of collaboration per countries. So here we can see that we have collaboration with the Denmark at 20%, with Germany 13%, with Italy 14%, with the Netherlands, with Ireland, with Belgium, United Kingdom, Malaysia, Austria, and United States. So we can deduce that 3D system as an international collaboration network on 3D printing. And lastly, we have the topics graphs that allows to visualize in which scientific domains are located the co-publication resulting from the collaboration between 3D system and the other organization. So this graph is dynamic. And for example, here you can see that the publications are mainly coming from the life sciences. And if you want to access the details of the subdomain, then just click on the fields to access the subdomains from which the co-publications are coming. Then we have some filters. So this is the benefit of the list is you can apply some filter to the list of collaboration to analyze in details the 3D system collaboration on 3D printing. So first filter is as a geographical filter that allows you to display only collaboration, for example, with Denmark or with Belgium or the Germany. So you can apply the filter at the level of the country or at the level of the continent. Then you have the select class filter. So this one, with this one, you can filter the list of the organization per type of organization. So for example, you can display only companies with which 3D system has collaborated to check if 3D systems has already collaborated or collaborates with your competitors. Then you have the topics filter. So this one allows you to filter the collaboration per scientific domains in order to display on which to display only the organization with which 3D systems has co-published on the scientific field which interests you. Then you have the scope filter. So the scope filter allows you to view the distribution of internal, so the closed network, or external collaboration, the external networks. So the propensity of an organization to collaborate with external organization can show that this organization is used to collaborate externally and can therefore be an interesting partner. Here we can see that 3D systems collaborate mainly externally. And finally, you have the perimeter filter. So the perimeter filters allows you to visualize the distribution of collaboration that are internal or external to your organization. In other words, in case you are a big company with a lot of division or a university with a lot of labs, the perimeter filters allows you to quickly see if 3D system has already collaborated with one of your division or one of your laboratories. So to summarize, all these filters allows you to assess the geographical and academic or industrial or dimension of an organization network on a research topic. So in our case, we see that on the topic 3D printing, 3D systems as mainly an academic networks. It collaborates mostly with laboratories. And we see that 3D systems collaborate especially externally, which shows that it can be an interesting partners. And we saw also that 3D system as mainly an international networks. So we have seen that with Expernova, you can evaluate the relevance of the scientific and technological expertise of an organization on your topic. And I would like also to show you the collaboration, the detail of the collaboration. So, so for example, we can see here that 3D System has collaborated with the University of Leuven. And to access the details of the collaboration, then click Open Connection here to access the detail of the collaboration. Here we have a form that displays the collaboration between the two organizations, and in the Why section, so one more time in the common expertise, you can double check the expertise of the organization. And in the Why, you have some elements that explain you why the collaboration between 3D systems and the University of Leuven is relevant on our topic. So we can see they have been working together on the topic for 20 years. They have recently published works on the topic, and they have both participated to a common project related to the 3D printing. And of course, it's clickable, so you can access the project to access the details of the project. So so of course you can do the same with the publication and the patent. And now that I've shown you how to evaluate the relevance of the scientific and technological expertise of an organization on your topic, I would like to show you how to visualize an expert collaboration network on a topic. So for that, I'm returning to the profile of 3D Systems to identify who at 3D System is working on 3D printing. So you remember in the people and work section here, Expernova has identified 102 persons, individuals working on our topic. So you click on them. And now, so the goal is to identify the experts from an organization who are working on your topic and access their expertise and their collaborative network. So here we have the list of the person at 3D System who has been identified as working on 3D printing. So to access an expertise, you need to display the profile of an expert, and to do so, for example, let's take the profile of Karel Lietaert. Just click on his name, just as we did for the organization. Then when you click on Karel Lietaert, and click on open to display the full profile. So we will do the same process. We will first go to the expertise to check the expertise of this person. So here we can see that he has an expertise on the additive manufacturing. And one more time, we will go to the why to get to understand the why this person is relevant on our research topic. So we can see that in terms of experience, he has recently published some works on our topic. Expernova has identified the 7 publications written by Karel Lietaert on 3D printing. So it's clickable, and so you can access the publication. And then in the network part, you can access to the collaborative network of Karel Lietaert. You can see the name of his best collaborator. You can see that the collaboration are located in 35 different countries, which show you that he has a big influence. And then we have also identified the 4 of the other experts of Karel Lietaert organization. So let's move to the collaborative network of Karel Lietaert on the 3D printing. So here it's exactly the same. We have Karel Lietaert in the middle, and all over we have all the persons with whom he has collaborated on 3D printing. You have the same information below under the form of a list. And here you have also some filters, so the geographical filter that allows you to target the collaboration per country. So here we can see that the people with whom Karel Lietaert has collaborated are mainly coming from university, and we can see, for example, we have several persons that coming from the mechanical engineering of the University of Leuven. And still the same, for example, if you want to go further and access the details of the collaboration, so for example, if you want to see what Karel Lietaert and Brecht van Oerweder have done together, click Open Connection to display the collaboration form that will explain you why the collaboration is relevant on our topic. So here we can see, for example, that they have recently published common work on the topic, and they have co-published 4 scientific publications, and it's clickable, so you can access them. So we saw that Karel Lietaert has a rather international network on 3D printing. And if we look at the affiliation of this researcher, we saw that they are mainly academic. So we can see that he has collaborated with a few experts affiliated with the Department of Mechanical Engineering from the University of Leuven. So we can say that on 3D printing, Karel Lietaert has a mainly academic and international network. So this information allows you to better visualize the area of influence of Karel Lietaert. And to sum up what we have just seen, we have checked that Karel Jettaert has an expertise on the subject additive manufacturing. We were able to access his scientific works on the topic. Access to the work of an expert, whether it is its publication or his patent, allows you to better understand his expertise. In addition, you can access the document publication dates that allows you to see if this expert is still active. And finally, we have access to his network of collaboration to assess the dimension of his network on the subject of 3D printing. So you can access also the complete profile of its collaborator as well as their expertise. And to do so, you just need to click on the name of the person to display their profile. So I would like to underline, let me go back to the search result interface. So in this demonstration, I focused on the network of 3D systems on 3D printing, both in terms of organization and people. But I want you to know that what I just showed you, you can do it from the search result interface. You remember, I enter my query, I click on the search button, and then from the expert list, people list here, and the company list, you can do exactly the same by clicking on an organization to display their complete profile in the same way we just did. So finally, we come to the third and final stage. That is to say, it is time to capitalize on the knowledge gain. So for this, the Expernova platform allows you to bookmark and export the expert profile, the organization profile, the list of experts, the list of companies. The graph can be exported too, so you can export everything. And that brings me to the end of today's webinar. So to conclude, let's summarize all that we've done. So today we have seen how from a few keywords you can easily access a global vision of collaboration between companies, universities, laboratories on your specific topic. We see how to simply navigate within this network of collaboration and understand who is working with whom and on which applications. We saw how to delve into the details of each collaboration thanks to rich and dynamic profile of expert and organization that show you the expertise of each actor, their influence and their works. And we saw how to access the works of this organization in a few seconds. So I also wanted to highlight that I did this webinar in a standard environment. However, depending on your needs, Expernova can create for you customized results interface, for example, with a focus on a specific geographical area. If you want to have only an American network, only an academic American network, for example. So if you are interested, do not hesitate to contact me. So I realize that I'm really late, so I propose you to go to the question. I will just take one question, and after I will directly respond to the other person with personalized answer. So there is a question related of the source of the collaboration network. So we are able to identify the collaboration from the co-publication. So it can be through the co-publication or the co-patent, or also to a common participation to a common project or a clinical trial. So remember that all the information that you will find in the Expernova platform is coming from the scientific works. Expernova is based on the analysis of the scientific works. A last question. So there are some questions related to the ranking of the organization. So how do we order the organization? So the algorithm to evaluate the relevancy include a lot of various criteria that are taken into consideration. But to make it simple, let's say that the algorithm is combining advanced techniques for information retrieval to 4 main criteria. First, the number of occurrences of the keywords into the document. So for example, with 3D printing, if you find in a publication 10 times the word 3D printing, it will be more relevant than a publication where you find it only one time. Then second criteria is the position of the keyword in the document, whether it is in the title or in the abstract or in the keywords. So he will have a different coefficient. Third criteria is the type of document. So each document has a specific coefficient. As an example, a scientific poster will have less weight than an article reviewed by a committee. And last criteria is the date of the document. The recent document have a higher coefficient, so we privileges the recent document. So this webinar is now finished, and for the question I did not answer, I will send you a personalized answer. Now it's your turn to use Expernova, and if you are not yet a user, please feel free to ask for a personalized demonstration at contacts@expernova.com. Thank you very much for your time, and bye-bye.